Last week, we were talking about a hypothesis test for proportions, and now we're going to transition and talk about a hypothesis test for means. Our question today is, are you getting enough sleep? It's recommended that teenagers get 8 hours of sleep. It's believed that you guys are getting less than the recommended 8 hours of sleep per night. So she took a random sample of 10 students in class, record the number of hours of sleep for each, and then we're trying to see if that data provides convincing evidence that students get less than 8 hours of sleep per night using a significance level alpha of 0.05 or 5%. So clearly we're not in class, so I would take a sample of all of you. However, I just texted all my group texts and got about 11 pieces of data. So here's my data. What I did was I typed it into my stat edit. There it is. And then I went over stats, over to Calc, and did one variable statistics and went calculate. So I have that written down here, stat over to Calc, one variable statistics. And here's my data. So I got a mean of about 6.39 hours and a sample standard deviation of 1.86 hours. There's my data. This was my sister-in-law, 4.8 hours, and this was my buddy whose baby didn't let him sleep last night. So I checked and made sure. We'll come back to that in a second. That is not an outlier. So moving right along, our hypotheses for the significance test. It's recommended that students get 8 hours of sleep, so we want our mean to be equal to 8. Our population mean for all teenagers to equal 8 hours of sleep, but we're worried that that actual number is less than 8. So mu is less than 8, where mu is the true mean hours of sleep. Conditions that we need to check and make sure that it's random. Poorly, but yes, it is random. That random people responded back to me 10%. So this says that our sample is less than 10% of the population, and these 11 people are definitely less than 10% of the entire population. And then we have to check and see that it's normal. This data wouldn't look too normal. We would be able to check and see if n was greater than or equal to 30 from the central limit theorem, or we can say that there's no strong skew or outliers. And thanks to my sister-in-law, that is actually not an outlier anymore. That's why I have 11 pieces of data and not 10. Formulas down here for our sampling distribution. Our population mean is going to be our sampling distribution mean, so that will just be our 8 that we're looking at, and then we're looking for our sampling standard deviation here, and we would take our our population standard deviation, but we don't have that, so we'll take our sample standard deviation divided by the square root of n, so that'll be 1.86 divided by the square root of 11, which gives us 1.86 divided by a square root of 11 gives us a 0.56. All that's well and good, but we're just going to go to our calculator. This is what we're looking at here. We want to see, here's our population mean. We want to see if it's less than here. So I think we have a 6.39. So we want to see how likely that is to occur. Here our label, instead of last class, we're talking about n, and then our mean and our standard deviation. We just have t here, so our t distribution. And then this is our df, degrees of freedom. Remember, that's n minus 1, so that'll be 10 because I had 11 in my sample, minus 1. This is our formula for t, and we're just going to use our calc and determine that when we find our p-value. So since we are working with means, we are talking about a t-value, and here's how we're going to do it. We could use a table, and I think you guys all have copies of the t-distribution table, but instead we're going to go to our calculator, and we're going to go stat over to test, and we're going to go to a t. So that was stat to the right to test, and we want number 2 is a t-test. On this t-test, we're going to use data because I have the data typed in. If I use stats, then I can just type in, and actually they already typed in all that for me. Our sample mean or sample standard deviation, our n value, that's all there for us, but we're just going to go to data. Our mu sub 0, that is from our null hypothesis, that's our 8. L1, that's where all my data is, and we are looking for mu is less than our 8, so we want less than, that's already highlighted, and we want to calculate, and that'll give us a lot of information here. That'll tell us our t-value is negative 2.87. Our p-value is 0.008, and then it confirms our sample mean, our sample standard deviation, and our sample size. So given our p-value is pretty low, it's in fact less than 0.05, what we would do is we would reject the null hypothesis that people are getting on average 8 hours of sleep a night, and instead we would say that there's significant evidence that people are getting less than 8 hours of sleep each night. We'll use a second to look here on the next page. This is page 13 in our notes. The conditions, test statistic, and our p-value, again, how to get our t-test. So while you're copying that down, let me zoom in a bit for you. The next video, I'm going to go through this, check your understanding real quickly, and then so you guys can try that on your own, and then check the next video. I'm going to cut out some of the things because we kind of just skipped over that T formula there. I'm not really going to expect you guys to be able to do that. Just go to the calculator and then be able to interpret the p-value from there. See you in the next video.